The sky dictates so much. A sudden downpour cancels plans. A heat wave sends us searching for shade. Farmers anxiously watch for frost. We all live by the weather. Knowing what is coming helps us prepare. For centuries we have tried to predict it. Early methods were simple observation. Red sky at night, shepherd's delight. Then came barometers, thermometers, science. Forecasters studied charts and patterns. Predictions got better, but weather remained tricky. It is a complex, chaotic system. Perfect accuracy always seemed just out of reach. Now a new player arrives. Artificial intelligence, or AI, promises a revolution in many fields. Weather forecasting is one of them. AI can process huge amounts of data, far more than any human. This could lead to much better forecasts, but is it truly a revolution, or is it just hype? AI thrives on data, lots and lots of data. Think of it as a hungry student. For weather AI, these books are vast datasets. They come from all over the globe and from high above it too. Satellites are key eyes in the sky. They constantly watch the Earth. They capture images of clouds. They measure sea surface temperatures. They track atmospheric moisture levels. This information flows in non-stop. Weather stations on the ground add more. They record wind speed, rainfall and air pressure. Every data point is a clue. Internet of Things or IoT sensors are spreading. Smart buildings have them, even some cars do. These provide hyperlocal readings. AI algorithms take all this diverse information. They learn to connect the dots. AI learns from the data it is given. This seems straightforward, but what if the data is not perfect? What if it has gaps or biases? This is a big challenge for AI weather models. If the historical data is skewed, the AI's predictions can be skewed too. This is known as data bias. Imagine an area with very few weather stations. The AI will have less information for this region. Its forecasts there might be less reliable. Predictions could be better for cities, worse for remote rural areas. This creates an inequality in forecasting. Some places get better information than others. Climate change adds another layer of difficulty. AI learns from the past, but our climate is changing rapidly. Past weather patterns may not hold true. Extreme events are becoming more common, events that are not well represented in older data. Can AI predict something it has never really seen before? Furthermore, building these AI models is complex. They need enormous amounts of data. They also need significant computing power. Some AI models are like black boxes. Data goes in, a forecast comes out, but understanding exactly how the AI reached its conclusion can be difficult. This lack of transparency is a problem. If a forecast is wrong, why was it wrong? Without knowing, it is hard to improve the system. Weather itself is incredibly complex. It is a chaotic system. This means tiny changes in initial conditions can lead to vastly different outcomes. Think of the butterfly effect. A butterfly flaps its wings in Brazil. This could, in theory, set off a tornado in Texas. AI is good at finding patterns. But true randomness and chaos are hard to tame. The computational power needed is immense. Training sophisticated AI weather models requires supercomputers, or at least very powerful computer clusters. These are expensive to buy and run. They also consume vast amounts of electricity. This raises questions about sustainability. Section 5. AI on the front lines, predicting nature's fury. Despite challenges, AI is already making a difference. The US National Weather Service is a prime example. They are increasingly using AI tools, especially for predicting extreme weather. Think of hurricanes. These are destructive and complex storms. AI helps to improve track forecasts. It can also predict intensity changes. AI models can process satellite imagery faster. They can analyze radar data more efficiently. They spot subtle cues that might signal a storm strengthening or changing direction. This can provide vital extra hours of warning. When a hurricane is approaching, every hour counts. More lead time means better preparation. It means saving lives and property. The National Oceanic and Atmospheric Administration, or NOAA, explores AI. They are developing new AI-based models. Some models are now outperforming traditional ones, especially for certain types of forecasts. For instance, predicting rainfall amounts or the likelihood of flash floods. This is not about replacing old methods entirely. It is about adding powerful new capabilities. It's important to remember AI is a tool. It is part of a larger forecasting system. Human forecasters still play a crucial role. They interpret the AI's output. Section 6. Sowing seeds of change, AI in the fields. Agriculture is deeply tied to the weather. A farmer's success often depends on it. Too much rain or too little can ruin a crop, and unexpected frost can be devastating. AI-powered weather forecasting offers new hope. It can provide farmers with more precise information and more localized predictions for their specific needs. Imagine a farmer receiving a forecast not just for the general region, but for their specific fields. AI can help with this. It uses data from local sensors. It considers topography and soil type. This micro-forecasting helps with critical decisions. When is the best time to plant? When to irrigate or when to hold back? When to harvest for optimal quality? AI can also help predict pest and disease outbreaks. Many plant diseases thrive in certain weather conditions. AI models can analyze weather patterns. They can flag periods of high risk. This allows farmers to take preventative action. They can apply treatments more strategically. This reduces crop loss. It also minimizes pesticide use. Better for the farm, better for the environment. Companies are now offering these AI-driven services. Section 7. Stronger together, the hybrid forecasting future. AI is powerful. Human expertise is invaluable. The future of weather forecasting likely lies in combining both. This is the idea of hybrid models. Think of it as a skilled pilot. The pilot uses advanced autopilot systems, but they are always there to oversee, to intervene if needed, to handle unexpected situations. AI can sift through enormous datasets. It can run complex simulations very quickly. It can identify subtle patterns that human forecasters might miss. This is its strength. It can provide a first draft of the forecast, a highly detailed, data-driven prediction. This is a fantastic starting point for any weather office. It saves time and effort. However, human meteorologists bring something AI lacks. They bring deep understanding of atmospheric physics. They have experience with local weather quirks. They can spot when an AI model might be going astray, especially with unusual or unprecedented weather events. They can also communicate forecasts effectively, explaining risks and uncertainties to the public. This human touch is essential. A hybrid system uses AI as a powerful assistant. The AI does the heavy lifting of data processing. Human experts then refine the forecast. Section 8. Beyond the Horizon, AI's true weather wisdom. So, is AI-powered weather forecasting a revolution or hype? The answer, like weather itself, is complex. It is not a magic wand. AI will not give us perfect, infallible predictions tomorrow. The inherent chaos of the atmosphere ensures that. There will always be a degree of uncertainty in forecasting. That is a fundamental truth we must accept. However, AI is undeniably a significant advance. It is a powerful new tool in our kit. It allows us to process more data than ever before. It helps us find new patterns. It is already improving forecasts for specific events like hurricanes, and it is providing valuable, localized information for sectors like agriculture. This is more than just hype. This is real progress. The key is realistic expectations and smart implementation. We must address the limitations. Issues like data bias and the black box problem need work. We need to ensure AI tools are developed responsibly and that their benefits are shared widely. The goal is not just more accurate forecasts, it is also more accessible and equitable information for everyone. The most promising path forward seems to be hybrid models. AI and human experts working together, each playing to their strengths.